Welcome back, Math 7. Today's lesson is continuation about translation. We're going to call it Translation Part 2. The reason being is because last time we only talked about one type of translation of the figure in a Cartesian plane, which was either vertical or horizontal. Today we're going to go some combination. So when I say about translation, first thing first, you need to understand that there's two types. Like I mentioned, along x-axis or along y-axis. In addition to that, it is important for you to understand that translation have to consider positions of the coordinate, which is original or how can I say translated, so afterward, and quadrant location, especially if there's any quadrant that changed. So we're going to do some examples to talk about these. Let's go through one example. Before I do, I like to create a Cartesian plane. Actually, it's one more. There we go. So, let's say we have a figure. A at 2, 2, E at 5, 1, D at 6, 2, 1, 2, 3, 4, 5, there you go. And let's say 5, 1, 2, 3, 4, 5. 5 and 5. Let's say we have C coordinate. And we also have coordinate at B, which is 3 and 5. Something like that. All right, so let's say we're moving or translating. How can I say? Move the figure. 7 units left. And 3 units down. So we have that situation where you need to move this entire figure. 7 units left and 3 units down. We can actually predict this without doing the bunny hop method. What I mean by that is this. A's coordinate is 2, 2. If you want to figure out the new position of coordinate position A, you just need to, it says 7 units left, that's minus 7. And you're doing 3 units down, which is minus 3. So we can apply the opposite operation. 2 minus 7 is minus 5. 2 minus 3 is minus 1. So even without using any type of bunny hop method, you can predict and then you can put the coordinate, the new coordinates. Let's do the other parts too. b, which is 3, comma 5. If you think about moving the coordinates b, gonna have new b coordinate, 7 to the left, 3 to the down. So there'll be minus 4, there'll be positive 2. That's our new coordinate. You don't have to do this for everything. I'm gonna tell you why. Because if you construct 2 or 3 points, so A's new position is 1, 2, 3, 4, 5, and minus 1. So that's my new A's place, which you need to put the new coordinates, by the way, negative 5 and negative 1. And B, we found that 1, 2, 3, 4, 1, 2. To the right, something like that. So, I'm gonna tell you why we don't have to move everything using the calculation, which is basic integer operation. As you may notice, B and C is just 2 distant apart. If I find a new position of B, I can easily find C's new position because it's just 2 units to the right of B. So that's why. Similarly, if I look at C and D's relationship, C, if I go 1, 2, 3 down, 1 to the right, you can create a new D's position. So 1, 2, 3 down, 1 right, that's new position D, which is minus 1, minus 1. Then E, which is minus 2, minus 2. Something like that. And you can create a new transform figured below. That is how you do multiple type of translation. Now, quadrant. My first object was located on quadrant 1, where x is positive, y is positive. When it comes to the second figure, those are located on quadrant 2 and 3. So it is a good idea to have that in your mind. Sometimes the question asks you about where does it move, those kind of things. So just for the heads up. All right, let's do one more. This time, let's say we have our figure on 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I like to give 5 or 10 a little tick so that we know where the object is about, the place and those kind of things. Let's say we have this A, B, C, D, E with coordinate position. A is located on negative 4, negative 1. B is located on negative 4, negative 3. C is located on negative 2, negative 4. D is located negative 1, negative 3. E is located negative 1, negative 2, something like that. Let's say we are basically translating these guys with the condition of move the figure 5 units right and 3 units down, something like that. Then in that case, let's use our what we learned today, applying bunch of calculation first and then move A prime, B prime, C prime, D prime, E prime, something like that. The first coordinate, which is x position, we're talking about anything that slide into along x-axis, sorry. And then we're moving 5 unit right, so that's negative 5. Negative 4 minus, moving 5 to the right, so positive 5. Negative 4 plus 5 is positive 1. Negative 4 plus 5 is positive 1. Negative 2 plus 5 is positive 3. Positive 4, positive 4. We can perform that calculation. Next part, 3 unit down. If you look at from the second coordinate perspective, that means we need to apply our whatever the integer position number minus 3. So negative 1 minus 3, that's negative 4, negative 6, negative 7, negative 6, negative 5. So we have these coordinates. Now that means A is 1, 1, 2, 3, 4, 1, 1, 2, 3, 4, 5, 6. Oh, the position is actually going quite low. A prime, B prime. C prime is 3 and negative 7. Sorry, the diagram actually go with our work page over here. D, 4 and negative 6. And E, which is 4 and negative 5. 1, 2, 3, 4, 5. Over here. Careful with what you count. And we notice that if I look at just E point, first of all, you move 5 to the right and 3 to down, so you get the idea that the total distance that is being traveled is this diagonal line that is combined with horizontal and vertical movement. This is another translation type, ladies and gentlemen. And I can say the original diagram is located on quadrant 3 where everything is negative and negative, and now it is located on quadrant 4 which is positive and negative. That is today's lesson.